Okay, so here's my x values and here's my y values. All right, well, I'll give you some x values to begin with, and they are, we'll go with -5, -2, 0, 4, and 10. So they're the x values. Now I've got a rule in my head, and I'm going to now apply that rule to these numbers, and I'm going to tell you what the y value is. I'm not going to tell you what the rule is, I'm just going to write down the y values. So I'll change colour. Okay, so that will be 5. That will be 14. That'll be 20. That'll be 32. That'll be 50. So here's the question. What is the rule that I'm using to change those x values into the corresponding y values? Well, let's use Desmos to help us. So the x values were -5, -2, 0, 4, 10. So -5, -2, 0, -2, 0, 4 and 10, and the corresponding y values were 5, 14, 20, 5, 14, 20, 32 and 50. All right, let's push the magic button and see if they form a pattern. Zooming out, well, what do you know? Check that out. They form a straight line. The rule must be a linear equation. Well, let's see if we can work it out. Now, what I'm going to do, I'm going to type in a general linear equation. Now, before I do that, let me just explain something. We just saw that an example of a linear rule is something like y equals, say, 2x minus 5. Another example might be y equals 3x plus 8. Another one might be y equals -4x plus 20. These are all examples of linear equations. And what you might notice is that they all form a sort of a pattern. They're all similar in some ways. They all seem to have a number in front of their x, like this. And they all seem to have a number or something added or subtracted at the end. And so we can come up with what we call a generalized type of linear equation, which is this. So if we just want to talk about a general linear equation, we can say y is equal to some number, I'll leave a gap there, some number times x plus or minus some number. Now, we call the number in front of the x, we give it a symbol. We call it m. And we call the number out here on its own, c. So all of these values here, sorry, there should be plus, all of those are the values of c. So the value of c in this equation would be plus 20. Here would be plus 8. Here the value of c would be minus 5. On the other hand, the values of m would be 2 in this case, 3 in this case, and negative 4 in this case. So that's what we call the general form of a linear equation. Okay, so let's now go back to Desmos and use that idea. So I'm now going to type in our general form. Y equals mx plus c. Now what it asks me to do, it's asking me, do I want to add sliders? And you bet I do. There they are. Now I'm going to, at the moment, this is set to m equals 1. So the value of m is 1 in this case, and the value of c is 1. And you'll notice it goes up as, here this is telling us how far up and down those values will go. But I want to change that. If I double click on that, I want to go down as far as negative 30, and I want to go up as far as positive 30. And I want to go in, sorry, that should be there, I beg your pardon, 30. And I want it to go in very small increments of 0.1. With my c values, I want them to go from negative 40, be able to go from negative 40 up to 60 in values, in steps of, well, we'll make it 1. So, now, what I can now do, I can now change the value of m and c on this line by moving my sliders. Now, watch this. Look what happens when I move my c slider. When I move it up, the equation moves up. But not only that, notice that when c equals 60, look, it's crossing the y-axis at a value of 60. When it equals 20, it's passing through the y-axis as 20. 0, now, no prize for guessing where it's going to cross through if I set it to negative 20. That's right, negative 20. So hopefully you can see that changing the c value, it doesn't change anything other than where the line is passing or crossing the y-axis. And that's called our y-intercept. So where it cuts the y-axis, where it's cutting here or crossing the y-axis, that's called the y-intercept. And it's our c value that tells us that. So, that c value is the y-intercept. Intercept, where it's crossing the y-axis. Let's now have a look at our m value. Now I'm going to set my c value back to 0. Now I'm going to change my m value. Whoa, check that out. As m goes up, it gets steeper and steeper and steeper. Now it could go even further, but I've set it to stop at 30. So the bigger the value of m, the steeper the graph. Now I'm coming down again. Now when it hits 0, look at that. It's a perfectly horizontal line. Now what happens if I go negative? Oh, look at that. It's getting steeper, but it's getting steeper in the other direction. So we could almost say that that's flat ground, that's uphill, and that's downhill. Flat, uphill, downhill. So, negative gradient, negative values of m, I beg your pardon, make it very, very steep and downhill, and the bigger the negative value, the steeper it is going downhill. So if you are moving from left to right, you'd be running down this hill really quickly. On the other hand, if m is positive, it's very uphill and it's very steep and uphill. So positive slopes are when m is positive, negative slopes are when m is negative. So between both of those sliders, we can control the steepness of the line and the position of the line. So why don't we do that to see if we can make this line match up with those points. So I'm going to try and do that now. So I'm going to make my line a bit shallower, so it's sort of matching the dots. I need to move it up a bit. Gee, I tell you what, that's it. I think we've nailed it. If we go along the points, 432, guess what? That's one of the points. Let's keep going. 1050, there's another point. Negative 5, 5, there's another point. So, guess what? We have now discovered the linear rule which all of these points and all of these points that we didn't plot, we've found the linear rule that's governing all of those. And the linear rule is y equals 3x plus 20. So there's the rule. Now, one thing I also wanted to say, remember we saw that this value for c controls where it cuts the y-axis, and m controls how steep the line is. This m value has a very special name. It's called the gradient. M is called the gradient. Okay. Thank you.